Hello. In this video today, we are going to go over position adjustments in ggplot. And if you're new to these videos, we're working within the tidyverse. So if you're just opening R for the first time, you install packages, tidyverse, and then load it into your library with its line library tidyverse. Okay, so today might be a little bit more mundane. We're going to be talking about bar plots and reiterating another facet to a scatter plot later in the video. So with bar plots, which are fundamental to statistics, histograms, proving your data, and stats, is always in a foundation by using a bar plot. Portraying the data is very important, and using some colors or filling the bars with said colors will make your plot more appealing to the eye. So using color will outline your bar plot with a color. We're using the diamond dataset, which is a predetermined dataset within R, which you can use as well. So ggplot data equals diamonds plus geom bar for a bar plot. In my previous video, I touched on different geoms, and I'll have that link above. So again, geom bar, our aesthetics, we're looking at the cut of the diamond, and then we're going to use a color. We're also doing coloring of the cut of the diamond. And as we can see here, it's a little bit difficult to see, but you can tell that the outline of each of these bars has an assigned color. The legend also shows that. The legend also shows the breakdown of the particular cut of diamond: fair, good, very good, premium, and ideal. Before moving forward, let's just get familiar with the diamond data set. View diamonds. We've got carat size, the cut, the color, the clarity, depth, table, price, X, Y, and Z. So that is our data set, and that is what we are pulling upon here and seeing within our bar plots. Now, I think we can all agree that this bar plot is difficult to tell, and the color really doesn't help. So it would be better if these bars were filled in. How do we do that? Well, using fill, we will fill the bars with the color. It's the same script as above here, but instead of using color equals cut, we use fill equals cut. I encourage you to type all of this out every time. For practice sake, you will avoid errors by doing so. So ggplot data is diamonds, X is cut, fill is cut. And we can see that these are now filled in with the respective colors. You may have a different color scheme on your end. Do not worry about that. The point being, we use the fill function to fill the bar. Okay. Now, what if we wanted to make a stacked bar chart? We know there are more variables in this data set, and only looking at the color of the cut, despite the bar reflecting the height or the quantity of observations for said variable, it might be more fortuitous to use a different variable from the diamond data set to portray your data. So by assigning the fill function to a different variable automatically stacks the bar chart for you. It's that simple. ggplot data equals diamonds plus geom bar. The aesthetics are X is the cut, but the fill is the clarity. And what we get below is various colors being filled in based on the clarity, which is assigned here in the legend. And we can see each cut quantity being reflected across the X, fair, good, very good, premium, ideal, and the quantity within each cut based by clarity. However, there are other ways to do this through other sorts of identity, dodge, or fill functions. For instance, position equals identity will place each object where it falls in the graph. Okay, we're going to do this twice. ggplot data equals diamonds, x is cut, fill is clarity, that is the same as above. Geom bar alpha equals 1 over 5. The alpha more or less says this is how transparent we want our colors to appear. 1 over 5 means it's going to be 1/5 the strength of that color. So instead of seeing it fully bold, it'll be a bit more faint. Position equals identity. And let's see what comes of this plot. Okay. We can see the same color scheme, more or less. It's a lot more faint. That's because, let's, for instance, look at the ideal cut. You can see behind this darker shade of green, this yellow bar is protruding from the back. That means the quantity of the ideal is a bit more than what we were maybe initially seeing, and so on and so forth. They overlap a bit. So this alpha value really does help elucidate our data a bit further. Now, if we use fill equals NA, we can make the plots fully transparent. Instead of alpha equals 1 over 5, we do fill equals NA. Now, remember, if you don't change it from fill, you'll have nothing on your plot. So we need to do color equals clarity instead of fill equals clarity. Fill equals NA, position identity, and we get a plot such as this. We can see the individual squares. Now, this is kind of an ugly chart because of the grid in the background. If you're content with this figure as it is, I would strongly recommend adding theme classic to the end of that script. This removes the background grid and makes this a lot easier to look at. Okay. Now, that is position equals identity. Position fill, on the other hand, stacks the bars but makes them all the same height, which is great for comparing proportions of your observations. Maybe you want to know what percent of a compound makes up your chemicals or soils or plants, etc., etc. Position fill can help. ggplot data equals diamonds, geom bar, x is cut, fill equals clarity, position equals fill. And we can see the x or the y scale goes from 0 to 1. Therefore, and what I said before, you're looking at proportions. So you can see that roughly, let's say, 10 to 15% of the fair cut is graded VS1 for clarity. This is also something that if you're looking at large quantities of compounds in your samples, can really help clarify what is maybe dominating. I wouldn't necessarily say it should be the sole driver for your figures in, say, a paper or a poster, but this is a really key tool to maybe give you an idea of where to look next. It's helping you tease apart your data. Okay, so that's position fill. Position dodge, on the other hand, will place the overlapping objects beside each other. So where position identity overlapped them, position dodge will stack them next to each other. Data is diamonds, geom bar, x equals cut, fill equals clarity, position equals dodge, and you get this plot. You have multiple bars. They're colored respectively based on clarity still. And now you can see the counts respectively for each cut and clarity. This is also a very useful plot. Rather than them being overlapped, you can point to them individually and identify their counts. Okay, now we're going to touch on a scatter plot once again, but we're going to be moving into the MPG dataset. MPG. This is also a part of R, so you do not need to download this. It already exists. We're going to be using the jitter function. Now, in a former video of mine, we've touched on the MPG. It looks at fuel economy data from 1999 to 2008 for 38 popular models of cars. We've compared engine displacement in liters and the number of cylinders and highway mileage per gallon. So if you've watched the previous video, this plot will look familiar. Data MPG, geom point, aesthetic, engine displacement in liters, and highway mileage. You get this scatter plot that has a downward trend. Now, if we were to look at this, I'm not going to have you count all of these out, but there are 234 observations within our MPG data set. This figure, I would say, looks to have quite a few less. The R for data science textbook that I've been working through, which is what these tutorial videos reflect, states that MPG has 234 observations, but this scatter plot only shows 126 points. Why might that be? Some of them might overlap, some of them might just not fit, but this is where the jitter function comes in. Using jitter, we can account for the remaining observations on the plot, add some randomness to that scatter plot. Slight jitter, it'll look a little bit blurry, the points will be less distinct, but they'll more accurately reflect the data that you have. So, same plot, data equals MPG, geom point, X is displacement, Y is highway mileage, position equals jitter, and now you have a lot more points shown. So you have some randomness there, which might not be entirely accurate to the exact location of each of these observations, but it is giving a stronger representation of the data that you have present. Gives you more statistical power. You have 234 observations. You should show all 234, not just 126. Okay. Position adjustments are key to some fundamentals of R. They don't necessarily drive your whole story of your data, but they can help guide you in the right direction and give you some strong stepping stones to head towards a more clear sense of what your data is trying to tell you. Please consider giving this video a like or subscribe to the channel. Leave your comments or questions down below. Thank you.